Let me ask you this. What's faster, a virtual machine that takes minutes to boot up, or a Docker container which takes less than a second to start? In this video, I'll show you why Docker beats virtual machines, break down Docker concepts every DevOps engineer must master, and then we'll install Docker together and run our very first container. And here's the twist. At the end, I'll give you a sneak peek into a real world debugging simulation, the kind of problem you'll see in production environment. So stick around till the end, because this isn't just a normal tutorial. This is a real world DevOps lab. If you want more hands-on DevOps content like this, hit subscribe right now and let's dive in. This is our virtual machine setup and this is our Docker setup. First, I am going to talk about virtual machine setup. So this is my hardware, my physical computer which I am using to record this video. In this, I will write it as PC. In this, we are installing an operating system. It can be anything: Windows, Linux, Mac, it can be anything. My PC has Windows operating system. On top of this, I am going to install a hypervisor. It can be VirtualBox or VMware Workstation or any other hypervisor you like. Then once again, we are going to create virtual machine on top of this hypervisor. So this is, let's say, the guest OS of that particular virtual machine. Let's say Ubuntu. We are going to deploy application in this Ubuntu operating system. So this is the whole setup of this virtual machine. If I have to deploy an application, I need to follow this whole process. Let's talk about Docker now. So in Docker, this is my hardware, same exactly PC, and on top of this I have my operating system, which is Windows. On top of Windows, I can install Docker and then launch containers. That would be these applications. So here I do not have lot of dependency. For example, here I have an operating system. Here I have hypervisor. Then followed by I have guest operating system. On top of this, I have application. In this Docker scenario, we are going to use the hardware and its host OS. Followed by we are going to install Docker and then run containers on top of this operating system. So the startup time here is very small when compared to a virtual machine, because on virtual machine the operating system image needs to start, whereas here we are using the host OS, so there is no need to install any kind of operating system. Normally we can directly run our containers. So that is the difference between a VM and Docker. I hope it is clear right now. I tried to explain in a very simple terms. Now let's jump into the Docker concepts. Now let's talk about Docker architecture and concepts. Let's talk about images first. So what exactly are images in Docker? An image is like a blueprint. It contains everything your application needs. For example, code, libraries, environments. If we pull Nginx latest image, I instantly get a ready to use web server. I don't need to do anything. I will just pull this image and run Docker container, and my web server is ready. As simple as that. We are not going to install anything. We will just pull this image, run it locally. That's it. My job is done. Let's talk about containers. What exactly are containers? A container is a running instance of an image. For example, Nginx. One blueprint, unlimited running instances. That's why you can run 10 containers of the same application. For example, I will take Nginx image and I can run 10 containers isolated, each isolated from one another. Now let's talk about layers. What exactly are layers? Docker images are built in layers. If we make a small code change to our code, Docker doesn't rebuild everything. It reuses existing layers and only build the changed ones. That's why Docker builds are efficient. Now let's talk about registry. What exactly is registry? Images need a place to live. That place is called registry. Default is Docker Hub. There are some other registries as well. For example, AWS ECR or Azure Container Registry, or you can use JFrog Artifactory. I mean, there are like say so many different places that you can store these images. That is called a registry. Finally, we are going to talk about the architecture. What exactly is the architecture? Docker is a client server model. The Docker client is your CLI. From your machine, you are going to run Docker commands, or we can run Docker Compose as well. That talks to Daemon, Docker Daemon, also known as Docker D. The daemon handles the heavy lifting, as you can see in this image. It handles the heavy lifting, building the images, pulling from registries, running containers. They communicate via REST API, usually over a socket. Here's the cool part. You can run Docker client on your laptop and connect to a daemon running in a remote server. This is how DevOps teams manage containers across massive production clusters. All right, enough of theory and concepts. Now we are going to install Docker on a fresh virtual machine. I am going to use the virtual machine which we created in DevOps full course. By the way, if you are new to my channel and wondering how do I even create a virtual machine to practice Docker on, I got you covered. I already uploaded a full 2 hours DevOps course on this channel where we go step by step, starting with setting up a virtual machine, configuring Linux, networking, Git, Jenkins, and more. That's the perfect foundation before diving deep into Docker and Kubernetes. I'll leave the link in the description and cards. Check it out after this video. Now let's actually install Docker on a fresh Ubuntu virtual machine. First, we are going to run sudo apt-get update -y, which will update our system. Followed by, we are going to install some dependencies. Clear the screen, and then we are going to install some dependencies. This is done. Followed by, I'm going to create a directory called etc apt keyrings. and then we are going to download the official GPG key from docker.com. Then we are going to set up the repository using echo dbn command. Now once again we are going to update our system so that the new repository packages are available to install. Then we are going to actually install Docker engine. So I'm going to install Docker engine, Docker CLI, Docker Compose plugin. Docker got installed successfully. I did not come across any kind of errors. Now let me clear the screen and verify the Docker version. For that, I am going to run docker space hyphen hyphen version. I can see Docker version 28.4.0 build is this. Now here comes the most interesting part. We are going to run our very first container. For that, I am going to say docker run nginx. Press enter. Cannot connect to the Docker daemon at Unix is the Docker daemon running. First debugging process starts here. Now we need to check if Docker is running. Sudo systemctl status docker.service. Press enter. I can clearly see failed. Failed to start Docker service. Let me close this. Once again, clear the screen. Let's try to restart the service and see docker.service. Press enter. Once again, let's try to check the status. Yes, it works. And then now let's try to run our first Docker container. For that, I'm going to say docker run nginx. Press enter. I'm getting an error. Docker permission denied while trying to connect to Docker daemon. Okay, this looks like a permission issue, clear permission issue. So how do we need to solve this? If you are seeing any permission denied issue, first we need to make sure Docker group exists. For that, I'm going to run sudo group add docker. Press enter. I can see Docker group already exists. That means we need to add our current user to the Docker group. So I will say usermod -ag docker and $user. It will try to add my current user to the Docker group. This step is important because by default, only root can access the Docker socket. Now for the changes to effect, we have two options. Either we are going to log out and log back in or just run new group Docker. Now let's try to run our first container, docker run nginx. Press enter. So what exactly is happening right now? Behind the scenes, Docker client sends a request to the daemon. Docker checks if the image, Nginx image presents locally. It says unable to find latest locally. Then it will try to pull the image from Docker hub. A new container is created and executed. Let's try to run our first container now. For that, I am going to say docker run hello world. Press enter. Here's what happens behind the scenes. Docker client sends a request to the daemon. Docker checks if the hello world image exists locally. If not, it will try to pull from the Docker hub. Exactly, if you see unable to find hello world locally, pulling from library hello world, followed by container got created and we can see a message hello from Docker. This message shows that your installation appears to be working correctly. In this episode, we started by comparing Docker versus virtual machine. Then we broke down Docker core concepts like images, containers, layers, registries, and the client server model. Finally, we installed Docker and ran our first container. In the next episode, we'll Dockerize a real web application, deliberately break it, and debug why it isn't accessible. This is where you will see how Docker is used in real production debugging. If you found this useful, hit like and subscribe and turn on the bell icon so you don't miss the next simulation. Remember, this isn't theory, this is a DevOps lab. And by the end of this series, you will be thinking and troubleshooting like a real engineer. Thank you for watching and see you in the next video.